Beneath the vast, sunless depths of the ocean lies one of Earth's most enigmatic and volatile landscapes, underwater volcanoes. These submerged giants, far more numerous than their land-based counterparts, remain shrouded in mystery due to their remote locations and the extreme conditions surrounding them. Unlike the dramatic, ash-plumed eruptions of terrestrial volcanoes, undersea volcanic activity unfolds in near silence, hidden from human eyes, yet it plays a crucial role in shaping our planet's geology, chemistry, and even the evolution of life itself. Formation and global distribution. Underwater volcanoes, or submarine volcanoes, form primarily at tectonic plate boundaries, where the Earth's crust is either pulling apart or colliding. The most prolific volcanic activity occurs along mid-ocean ridges, such as the Mid-Atlantic Ridge and the East Pacific Rise, where magma wells up from the mantle, creating new oceanic crust in a process known as seafloor spreading. In contrast, subduction zones, where one tectonic plate dives beneath another, generate explosive volcanic arcs like the Chromatic Tonga Trench and the Mariana Arc. Additionally, hotspot volcanoes, such as those forming the Hawaiian Emperor Seamount Chain, arise from stationary plumes of molten rock punching through the Earth's crust, regardless of plate boundaries. The Pacific Ring of Fire alone hosts about 75% of the world's underwater volcanoes, with thousands of seamounts, some towering over 10,000 feet, 3,000 meters, from the seafloor, remaining largely unexplored. Recent sonar mapping expeditions have revealed that the ocean floor is far more geologically active than previously thought, with new volcanic vents and seamounts being discovered every year. Eruptions in the deep, how underwater volcanoes behave. The immense pressure of the deep ocean, reaching hundreds of atmospheres, profoundly alters volcanic behavior. Instead of violent, explosive eruptions, deep-sea volcanoes typically produce effusive lava flows that cool rapidly upon contact with seawater, forming the distinctive pillow lava formations that resemble stacked sacks of molten rock. However, in shallower depths, less than 1,000 meters, eruptions can become more explosive as water flashes into steam, fragmenting lava into ash and volcanic glass. One of the most dramatic recent examples was the 2022 eruption of Hunga Tonga Hunga Ha'apai, which sent shockwaves around the globe, triggered tsunamis, and ejected volcanic material 36 miles, 58 kilometers, into the atmosphere, higher than any recorded eruption in history. This event underscored the potential hazards of shallow submarine volcanoes, which can disrupt shipping, damage undersea cables, and even influence global climate by releasing vast amounts of sulfur dioxide. How do they work? When magma reaches the ocean floor, the interaction with cold seawater results in unique eruption styles. The lava often forms pillow basalts, bulbous, rounded shapes that resemble underwater sculptures. In some cases, these eruptions can trigger earthquakes, hydrothermal activity, and even tsunamis if they occur near coastal areas or generate large undersea landslides. Unlike terrestrial volcanoes, submarine eruptions are rarely explosive due to the immense pressure of the water above. However, in shallower areas, gas buildup can cause dramatic explosions, sometimes breaching the ocean's surface. The role in Earth's ecosystem. Underwater volcanoes are not just geological curiosities, they are ecological powerhouses. Around hydrothermal vents, where volcanic activity heats seawater to extreme temperatures, entire ecosystems thrive. These vents release minerals like iron, sulfur, and manganese, feeding bacteria that serve as the base of unique food chains. Creatures like giant tube worms, deep-sea crabs, and ghostly octopuses live in these extreme environments, many of which are found nowhere else on Earth. These ecosystems provide crucial insights into life's ability to survive without sunlight, and even raise possibilities for life on other planets or moons with similar underwater conditions, like Europa or Enceladus. Monitoring and discovery. Studying underwater volcanoes is challenging. The ocean's depth and darkness demand the use of submersibles, remotely operated vehicles, ROVs, and sonar mapping. Still, groundbreaking discoveries are being made. In recent years, scientists have observed live underwater eruptions and mapped massive volcanic systems previously unknown. Seafloor observatories and instruments like hydrophones now help detect submarine eruptions in real time, improving our understanding of how these volcanoes influence climate, marine chemistry, and geological hazards. The frontier ahead. Despite advances in technology, more than 80% of the ocean remains unmapped and unexplored, meaning countless underwater volcanoes await discovery. As researchers continue to probe the ocean's depths, these hidden giants promise to reveal more secrets, not only about Earth's interior but about the origins of life and the dynamic forces shaping our world. Life in the abyss, hydrothermal vents and extreme ecosystems. Perhaps the most astonishing discovery related to underwater volcanoes is the existence of hydrothermal vent ecosystems, where superheated, mineral-rich water, reaching 750 degrees Fahrenheit per 400 degrees Celsius, spews from cracks in the seafloor. These vents, often called black smokers due to their dark, particle-laden plumes, support thriving communities of organisms that rely not on sunlight, but on chemosynthesis, a process where bacteria convert toxic chemicals like hydrogen sulfide into energy. These extreme environments host creatures found nowhere else on Earth, including giant tube worms, Riftia pachyptila, which grow up to 8 feet, 2.4 meters, long and lack digestive systems, relying entirely on symbiotic bacteria. Yeti crabs, Kiwa hirsuta, fuzzy-clawed crustaceans that farm bacteria on their arms. Ghostly octopuses and iron-shelled snails, Chrysomalon squamiferum, whose armor-like scales are fortified with metallic sulfides. Scientists believe these ecosystems may hold clues to how life began on Earth, and whether similar environments could exist on icy moons like Europa or Enceladus, where subsurface oceans may harbor volcanic activity. Scientific and environmental importance. Underwater volcanoes are not just geological curiosities, they play a vital role in Earth's systems, regulating ocean chemistry. Hydrothermal vents release minerals like iron, manganese, and sulfur, which influence marine nutrient cycles. Carbon cycling. Submarine volcanoes may act as both sources and sinks of carbon dioxide, affecting long-term climate trends. New land formation. Over millennia, volcanic eruptions can build seamounts that eventually breach the surface, forming islands like Surtsey, Iceland, and Nishinoshima, Japan. The future of exploration. Despite their significance, less than 25% of the ocean floor has been mapped in high resolution, leaving countless underwater volcanoes undiscovered. Cutting-edge technologies like autonomous underwater vehicles, AUVs, deep-sea drones, and 3D seismic imaging are revolutionizing our understanding of these hidden fire mountains. Projects like the Seabed 2030 initiative aim to map the entire ocean floor by 2030, potentially revealing thousands of new volcanic sites. As research continues, scientists hope to unlock secrets about Earth's mantle dynamics, deep-sea biodiversity, and even early planetary formation. Underwater volcanoes remind us that, despite humanity's advances, some of the most powerful forces on our planet remain hidden in the abyss, waiting to be explored.